All right, let's dive right in. Welcome to an explainer that is literally going to flip the script on how we view the future of artificial intelligence, and more importantly, our place in it. For a long time now, the narrative around AI has been pretty much dominated by this singular, honestly terrifying theme of human replacement. But the materials we're digging into today present a radically different, highly empowering vision. We're going to explore this brilliant concept of the working dog of Web3 and look at how decentralized local AI infrastructure is actively being built right now to preserve and actually amplify human agency.
So we constantly hear this doom and gloom narrative, right? The fear that automation just means we're all going to become obsolete. But what if these incredibly powerful AI models are actually just sitting there waiting for us to take the leash? Think about it for a second. The historical relationship between humans and working dogs, whether we're talking about herding, guarding, or hunting, is based on this incredibly nuanced, reciprocal partnership. The dog is deeply valued for its highly specialized capabilities, while the human provides the care, the direction, and the overarching intent. And looking at AI through this specific historical lens, it completely changes the equation.
This analogy from our sources is just brilliant because it totally reframes AI. Think about it. A highly capable working dog isn't somehow diminished by doing its job, and a human isn't suddenly made redundant just because the dog can run faster. The relationship works flawlessly provided it remains reciprocal, and, this is the crucial part, provided we remain the owners who actually dictate the goals. You see, automation really only equals replacement if we define human value exclusively as performing narrow, repetitive tasks. When we elevate ourselves to the role of directors and collaborators, the entire ecosystem actually expands.
Section 1. Escaping the giant kennels.
But here's the thing. Right now, we have a massive structural problem when it comes to who exactly owns these digital dogs. If only giant enterprise cloud monopolies control AI, it's basically like a few massive kennels owning every single working dog in the world. You're just renting their labor, and they can absolutely pull the leash back at any time. Every single prompt you send leaves your network, racking up endless API fees and leaving you subjected to completely opaque models and censorship risks. But when we talk about local AI, running these models on small business servers or even your own personal hardware, every individual can own their own sovereign digital partner. You get complete data sovereignty, literally zero API fees, guaranteed privacy, and the ability to work entirely offline. It's essentially digital sovereignty applied directly to artificial intelligence.
Now I want you to consider this number for a second. 100 million. It sounds huge, but a rigorous cost-benefit analysis from the sources shows that if you or your business process more than 100 million tokens per month, running a local, open-source model actually beats cloud API costs outright. The break-even point is surprisingly low. The performance gaps across these local deployments are narrowing dramatically compared to the massive differences in hardware costs. So what this means is that owning your own AI isn't just some cypherpunk dream anymore, it makes absolute, undeniable financial sense.
So this entire shift to local AI, it's not just ideological. It is being pushed forward incredibly fast by four undeniable forces. First up, complete data privacy. For legal, healthcare, or financial firms, data literally cannot leave the building, full stop. Second, strict new regulations, like the EU AI Act, are forcing organizations to document exactly where their AI processed data flows. Third, like we were just talking about, the raw economics and cost efficiency of running local inference at scale is undeniable. And fourth, offline and edge deployment capabilities. This allows these digital dogs to operate on aircraft, out on ships, or inside secure, air-gapped facilities completely without an internet connection.
Which brings us to Section 2. Digital identity and trust.
Okay, so if we all have our own sovereign local agents running around operating independently, how on earth do they trust each other across a global network without some centralized referee like Google or OpenAI stepping in? Well, the answer lies in a new Ethereum standard called ERC 8004. Think of this as an incorruptible ID card, or like a global passport specifically for AI agents. Say an enterprise-grade AI agent needs to dynamically hire a specialized auditing agent from a totally different organization. It needs absolute proof of identity. ERC 8004 allows them to verify each other autonomously across disparate protocols. The agent's history and its address remain totally consistent, irregardless of which underlying language model or server is powering it in the background.
This protocol neatly solves what is known as the trust gap. It mathematically answers three massive questions for these machines. First, identity. Who the agent actually is. That's solved by that persistent global passport to prevent malicious clones. Second, reputation. which solves the hallucination problem by attaching portable reputation scores, so one agent immediately knows if another has a history of logic failures. And third, validation. This is cryptographically proving that the agent executed a specific task correctly without tampering, using zero-knowledge machine learning, or ZK-ML proofs. Basically, this means the agent can prove to the network that it did the math correctly without ever revealing the underlying sensitive data. It's a total game changer.
And look, when these agents are out there doing real, consequential work, they can't just wing it. They require a highly structured database. An LLM acting as a friendly chatbot is one thing, but an autonomous agent needs a robust architecture, much like a tiered memory stack. This separates a short-term workspace for immediate tasks from episodic logs and deep semantic knowledge. And this is absolutely critical because in these autonomous pipelines, one AI model's output very often becomes the direct input for another autonomous agent. Without this kind of structured asset management, those handoffs would just completely break down.
So enter DeFi, or Decentralized AI Fabric. This is incredibly cool. Think of it as a decentralized compute exchange. It's an entire ecosystem where these trusted, verified agents can actually route tasks, lease idle GPU power from anywhere in the world, and then verify the generated intelligence entirely on-chain. It essentially transforms raw computation cycles into a fluid, composable asset class. To put it simply, DeFi is to artificial intelligence compute exactly what DeFi was to liquidity. Moving right along to Section 3, Bridging Code to Reality.
All right, we've talked a lot about agents thinking and storing memories and leasing compute power up in the cloud. But how do these abstract digital agents actually affect the tangible physical world around us? I mean, how does a digital dog actually fetch a physical stick? The answer is this monumental architectural leap called a semiotic bridge. It is the critical link that translates our complex, messy, and frankly often abstract human intent into direct, deterministic, and physical actions in the real world. It is quite literally the bridge between the global internet of data and the local internet of physical edge devices.
This entire bridge gets built out using something called the ERC 7827 framework. It's a step-by-step flow that takes abstract data all the way down to physical hardware. Step 1 securely anchors a data request on-chain. Step 2 takes that and wraps it in a defined legal entity. Step 3 actually tracks the human effort expended. And finally, Step 4 takes that verified on-chain action and trickles it all the way down to trigger physical execution at the edge, something like an electrical pin physically turning on a motor or unlocking a smart door in your house. I've got to say, I absolutely love this visceral terminology from the sources, the record of sweat. In a world that is just so obsessed with abstract digital tokens and automated bots, this concept grounds cryptographic data right back into the gritty reality of physical effort. It proves mathematically that real human work, real tangible effort actually took place out there at the very edge of the network. It's just a beautiful way to marry a digital ledger with physical reality.
And finally, Section 4, Preserving Human Agency. When you actually piece all these Web3 standards together, the local AI models, the ERC 804 trust passports, the DiFi compute networks, and those ERC 7827 physical bridges, a really empowering vision of the future starts to emerge. This technology exists to expand human capability, absolutely not to replace it. We just transition our roles. We become the pilots. We provide the complex intent, the overarching goals, and the moral direction. Meanwhile, our decentralized, sovereign working dogs, these agentic cells, they execute the deterministic sweat. They handle all the repetitive heavy lifting, the cross-chain routing, and all those complex cryptographic verifications.
The crazy thing? This decentralized infrastructure isn't science fiction anymore. It is already here, capable of sitting right on your own local hardware. We've officially moved from theoretical blockchain states to a working architecture that can physically react to the digital universe. So the only real question left for you is this. When these bit-perfect promises start orchestrating reality right in your own living room, using tools that you completely own and control, what are you going to program them to do? Thanks so much for joining me on this explainer, and I will see you next time.